Good afternoon and welcome to NASA's Kennedy Space Center in Florida, where excitement is building for the launch tomorrow morning at 6:20 a.m. of a SpaceX Falcon 9 rocket with the Dragon payload on the SpaceX Commercial Resupply Services Flight number 5 to the International Space Station. Today we are here to talk about NASA's fourth New Earth Science mission to launch in the past 11 months. The Cloud-Aerosol Transport System, or CATS, will begin its journey to the space station tomorrow on the SpaceX CRS-5 launch. CATS will be NASA's second external payload dedicated to 24/7 scientific observations of our home planet. CATS is a new laser technology developed at NASA's Goddard Space Flight Center that will measure clouds and small particles in the atmosphere, key players in Earth's climate system. And we're pleased today to be joined by our panelists to talk about CATS. To my left is Julie Robinson, Chief Scientist of the International Space Station Program from the Johnson Space Center in Houston. To Julie's left, Robert or Bob Swap, Program Scientist in the Earth Science Division at NASA headquarters in Washington, D.C. And to Bob's left, Matt McGill, CATS Principal Investigator from NASA Goddard Space Flight Center in Maryland. We'll begin with some presentations, and then after the presentations, we'll be happy to take questions from media and social media. Good afternoon and welcome to NASA's Kennedy Space Center in Florida, where excitement is building for the launch tomorrow morning at 6:20 a.m. of a SpaceX Falcon 9 rocket with the Dragon payload on the SpaceX Commercial Resupply Services Flight number 5 to the International Space Station. Today we are here to talk about NASA's fourth New Earth Science mission to launch in the past 11 months. The Cloud-Aerosol Transport System, or CATS, will begin its journey to the space station tomorrow on the SpaceX CRS-5 launch. CATS will be NASA's second external payload dedicated to 24/7 scientific observations of our home planet. CATS is a new laser technology developed at NASA's Goddard Space Flight Center that will measure clouds and small particles in the atmosphere, key players in Earth's climate system. And we're pleased today to be joined by our panelists to talk about CATS. To my left is Julie Robinson, Chief Scientist of the International Space Station Program from the Johnson Space Center in Houston. To Julie's left, Robert or Bob Swap, Program Scientist in the Earth Science Division at NASA headquarters in Washington, D.C. And to Bob's left, Matt McGill, CATS Principal Investigator from NASA Goddard Space Flight Center in Maryland. We'll begin with some presentations, and then after the presentations, we'll be happy to take questions from media and social media here at Kennedy Space Center and on the phone bridge. And also, if you're watching online, you can post a question using the hashtag AskNASA, and we'll field questions from you as well. So we'll begin with Julie.
Thanks, Mike. You know, we say that the space station is off the Earth for the Earth, and in no case is this as obvious as when we launch our science instruments to help in managing and understanding our home planet. The space station is maturing as an Earth and space science platform in a way that I don't think people really imagined it would. Once you have this extraordinary platform in space, you can support dozens and even as many as 30 different Earth observing instruments, also astrophysics instruments and technology demonstration payloads. And this really gives us a great opportunity to test payloads before they would go on a free-flying satellite. Almost every SpaceX flight, and this one included, is going to be bringing up either an Earth science payload or some kind of systems hardware like the docking adapter that will be going up in the coming year. And by 2018, we'll only have 1 to 2 available slots of over 20 slots. Everything else will be occupied by different instruments. And we'll even begin to rotate instruments. For example, the HICO instrument, which was a hyperspectral instrument for looking at the coastal ocean, is now going to be retired. It's come to the end of its life, and that will be brought down, and a new instrument can be put in its place. And that's really unique. There's no other satellite platform where you can do that. Take something that's worn out, discard it, bring up something new, and trade it out. And some of the things about the space station that make it totally unique are the fact that it's about 400 kilometers. A normal Earth remote sensing satellite is at over 800 kilometers, so it's about twice as close to the Earth. That lets you use lower powered optics to get the same resolution or to get higher resolution depending on the science interests. It has a different orbit, which lets you see the Earth at different times of day rather than at the same time of day. It precesses, it goes around the Earth every 90 minutes, so it's completely unique compared to the normal Earth remote sensing orbits. Now, for a while that was seen as a drawback, but now scientists are starting to see that as an advantage, and you'll hear about that today. The RapidScat payload, which went up on the last SpaceX launch, has been already operating well and has already helped scientists to manage the impacts of several different hurricanes that we're developing by using that wind speed data. And so what we're seeing is Earth science as it matures on ISS can really be a help back here on Earth, both to understanding the climate, to managing disasters, and to helping us to understand the Earth as a system. So with those as sort of overall remarks, I'll turn over to my colleagues to tell you more specifics about the CATS payload itself.
And what CATS allows us to do is to get a better thank you. Good afternoon, everyone. This has been a big year for us at NASA Earth Sciences. As we heard earlier, Mike was saying, this is going to be the fourth launch of a Earth Sciences mission in the last, the fourth of 5 launches in the last calendar year. And we're particularly excited about CATS tomorrow because CATS is going to focus on something that's very important to us in the Earth Sciences, and that's aerosols. In addition, and what I want to do is take a step back for a moment and tell you a little bit about aerosols and why we should care. This becomes important as simply stated, aerosols are suspended particulate matter, and it can be of almost infinitesimally small sizes, all the way up to something that you can see with your eye. And why it's important to us is that it can affect the way that we live in terms of health. It can affect our health, whether you breathe in, respiratorily, from the respiratory system, but it can also affect the way that the Earth's radiation balance is impacted, because wherever these aerosols are found, whether different altitudes, different composition, they can change the way that the sun's incoming solar radiation is either reflected or absorbed, and in the process it can change the way the Earth's radiation balance. What's also interesting to note, when we're talking about these aerosols, and this is something I think you and your readers and people who follow you can understand, is they come from various sources. And what CATS allows us to do is to get a better handle on these different types of sources. Mineral aerosols, like the great dust storms that you see, biomass burning aerosols from the large fires and the not so large fires that you see across the planet, marine aerosols, sulfate aerosols that come out from biogenic sources, and more importantly, industrial aerosols. So what CATS is going to allow us to do is to better source type these things. So it'll give us a handle on where they're coming from and how they're being supplied. In addition, what CATS is going to allow us to do is in the vertical have a good understanding of where these things are located. And this becomes important, as I'll show you in a couple of slides. So what I'm going to do is step you through 3 slides. If I can have the first one now, please. And what we have is an image of South Asia. And this is a region that we know that is known to supply a lot of aerosols with the Indian subcontinent. And when we right now, currently with Earth Sciences, are able to have a pretty good handle on this horizontal extent. If I can have the next slide, please, show you an image of aerosols detected by the MODIS instrument in space on the Terra and Aqua platforms. And what you see here in the different colors is essentially locations of different aerosols, with the warmer colors being more intense concentrations. Now, what we've done since then is we've been able to combine the horizontal with the vertical. And if I could have the next slide, the spaceborne LiDAR that is currently up there is known as Calypso. And what that can do is that can give us a sense of where clouds are and where aerosols are in the vertical. And when you combine the horizontal and the vertical, you can better constrain these things in terms of how they're located and where they're located. And what we do is we take that information, if I could have the next slide, please, and we feed it into complex Earth-observing system models. And what I'm showing you here is model output from the Goddard Earth Observing System model 5, version 5. And what you see are the different colors. So the white colors again are the blue colors are oceanic marine aerosols. The white colors are industrial aerosols or anthropogenic aerosols. The red colors are mineral dust, and then the green colors that you see are biomass burning plumes. Now, by being able to better constrain where these aerosols are occurring in time and space, both horizontally and vertically, we can get a better handle on how the Earth system is changing. And we can also have a better understanding of how the radiation balance is changing. This kind of information that CATS will provide with its high spectral resolution that we'll hear a little bit about just now, we'll be able to better constrain these models and hopefully have a better handle on how we move forward, predicting how the Earth is going to change. And with that, I'm going to pass it over to my colleague from Goddard Spaceflight Center, Matt McGill.
Folks always have. They assume
Bob.
we have three
Excellent
wavelengths,
job
we
of
must have
saying
three
the
separate
why and
lasers.
wherefore of the
We
science
don't. We
case.
generate all three from the same
CATS is a
laser unit.
spectacular opportunity to now
by using
utilize
pump
the
diode
International Space
and
Station
optical crystals in
to
the
achieve
system
important
with a
Earth science
second animation
measurements
that
at a
can show
modest
you,
cost.
how,
The goal of CATS is to measure and
generate
characterize
1064
worldwide
reddish
distribution
light,
of clouds
double
and
that to
tiny
green,
airborne particles, or
triple it to
aerosols,
355
as Bob
ultraviolet.
explained, in the
All
Earth's
three of these get
atmosphere.
transmitted
As the
in
first
discrete
Earth science
groups into the
instrument from Goddard
atmosphere.
Spaceflight Center
Simultaneously, they go
going
down.
to the International
And because
Space
the speed of
Station,
light is constant
CATS will
and
provide
known,
capabilities that haven't
timing
been demonstrated
electronics
before
can time
from
the difference
space.
between the emission of the pulse
Now,
and
CATS
when
is a
you see
laser
the
remote
return
sensing
signal.
instrument, or
That tells
LiDAR.
us that very
Works a
critical
lot like
aspect, which is
radar,
the
but
height
using
in the
low energy
atmosphere
pulses
that
of
the scattering
visible and near
occurs.
visible laser
That's
light.
what Bob was alluding to. That's what's missing
We have
right
a
now.
animation to show you
Now, these
of
detailed
construction of
observations of
CATS.
clouds
You
and
can see the
particles in
size
the
of it. It's
atmosphere, they're
about the
important for
size of a
lots of reasons,
refrigerator,
but
has a
three
60
key
centimeter
uses,
telescope in the
to
center,
address are,
and there are two
providing
lasers.
information on
Each one
real-time
has
hazard
different
events,
characteristics
like
there to
volcanic
test different
eruption,
technologies.
for studies of
And we use
energy balance
special
or
photon
climate
counting
change,
detectors to
and
receive
for
the
examining the
signal.
effects of both natural and man-made
Overall,
pollutants
I'd say
on
CATS
human
packs
health
a
and their
significant
quality,
capability
health effects.
and technology into that
Examine
box
each of
about
those
the
three in a
size of a
little more
refrigerator.
detail.
The LiDAR works
part about
by
hazard
sending
events
discrete pulses of
pretty
laser light
obvious.
into the
If
Earth's
there's a volcanic
atmosphere and
eruption,
detecting the
you wanna
tiny,
know
tiny fraction of that
where is
light
it,
that
what height in
scatters
the
straight
atmosphere is
back
it? You
towards
certainly don't want
our collecting
airplanes flying
telescope.
into it. And, depending
To
on
do
where
this,
the
we're using
eruption
three
is, there can
wavelengths
be
of light,
significant health
1064,
impacts
532, and
from the fallout
355
of the
nanometers,
plume.
which of course points to
CATS
one of the
gives you the
biggest
top bottom of
misconceptions
that
folks
plume.
always
That's
have.
exactly
They assume
what
if
we
we have
need.
three
Second,
wavelengths, we must have three separate
although we talk
lasers.
a lot about
We
aerosols
don't. You
and
generate
particles,
all three from the
CATS
same
permits
laser
studies of
unit.
clouds.
By using a
clouds are
pump
one of the largest
diode
uncertainties
and
right
optical
now
crystals in the
predicting
system, we have a
climate change
second
because
animation
clouds are
that can
the
show
key
you
determiner of
how
the planet's average temperature.
generate the
But to
1064
create more
reddish
accurate
light,
climate
and then
models,
double that to
we need
green,
more accurate
triple it to
representations
355 or ultraviolet.
clouds to
All
put in
three of
the
these
models,
get
so we need some more
transmitted in
information
discrete
on which
groups
to
into
base
the
the models.
atmosphere. Simultaneously, they go
information
down.
CATS can provide.
And because the speed of light
Third,
is
small
constant and
particles such as
known,
dust blown from deserts
timing
or,
electronics
smoke
can
from
time the
severe
difference
fires
between the emission
or
of the pulse and when we see the
pollutants.
return
They can
signal.
have significant
That tells
impacts
us
on
that very critical
climate and
aspect,
human
which is the
health
height in the
and air
atmosphere
quality.
that the scattering occurs.
So this data
That's
from
what
CATS
Bob was
will be
alluding
used
to. That's what's
improve
missing
computer
right now.
models of the cloud
Now, these
aerosol
detailed
particles.
observations of clouds
Because the
and
vertical
particles in the
distributions,
atmosphere,
as
they're
Bob
important for lots
said,
of reasons,
are
but
often
three key
poorly
uses
resolved in the
to
microphysical
address are
properties of what type of
providing information
stuff
on
is it?
real-time
Is it
hazard events
dust?
like
Is it
volcanic
smoke? Is it
eruption,
pollution?
for
Those
studies
often
of
aren't very well
energy
characterized in
balance or
models,
climate
and it
change,
matters a significant
and for
deal.
examining the effects of both
And to
natural and
improve the
man-made
quality of those
pollutants on
simulations
human
at
health
this
and air
point,
quality.
we have to have
health effects.
real-time data about
Examine
that
each
part
of those
the
three
height
in a
and
little
height.
more detail.
Now, that's what the LiDAR can
The part
provide,
about hazard
and in
events
particular,
is
the
pretty
vertical
obvious. If there's a
information.
volcanic eruption, you
And
want to
we have
know
an animation, a
where
flipped
is it, what
animation
height in
to
the
show
atmosphere
that
is it.
as
You
we
certainly
orbit
don't want
along,
airplanes flying
we build
into
up
it.
this profile
And
information
depending on where
showing
the
the height
eruption is,
and
there can be
location of the
significant
different
health impacts
features in the
from the
atmosphere.
fallout of the plume.
What's important here is
CATS
this
gives
data
you
is
the
going to
top
be
bottom
coming
of
to the
that
ground
plume. That's
in
exactly what we need.
continuous near real-time
Second,
fashion. That's a capability
although we talk
that's
a
made
lot about
possible
aerosols
by
and
the space
particles,
station,
CATS permits
space
studies
station
of
communication
clouds.
infrastructure.
And
We should
clouds
be
are
able
one
to
of the
collect
largest
the data,
uncertainties right now
transmit it to
in
the
predicting
ground,
climate
and have it
change
into the
because
models
clouds are
within
the
about
key
a 2-hour
determiner
time frame.
of the planet's
That's
average
something we haven't
temperature.
been doing before.
But to create more
And
accurate
it's
climate
something that's,
models,
at this
we
point,
need more
uniquely
accurate
enabled by the space
representations
station's communication
of clouds to
infrastructure.
put in the models, so we need some more information on which to
In
base the
summary,
models.
then,
That is
CATS was a
information CATS can
low-cost,
provide.
cost-effective way
And third, small
to
particles
utilize
such as
the
dust
space
blown from
station
deserts
demonstrating
or
technologies.
smoke from severe
As
fires
Julie said,
or
the station's built,
pollutants,
it's there. We can
they
use
can
the
have
infrastructure.
significant impacts
Cargo
on
rockets are going there.
climate
We launch
and
as
human
cargo,
health
essentially.
and air
That
quality.
keeps the cost very,
So this
very
data
low.
from CATS will be used to
Lets us,
improve
turn
computer
things around
models
very quickly.
of the
We
cloud and
can take
aerosol
more risk
particles.
because it's a
Because the
demonstration
vertical
measurement,
distributions, as
and it's a
Bob
demonstration of
said, they're
technologies.
often poorly resolved in the
But these
microphysical properties
demonstrations
of
and
what
these new
type
measurements
of
will
stuff
find their
is
way
it.
into
Is
future
dust? Is it smoke? Is it pollution? Those often aren't very well characterized in the models, and it matters
and
a
being able to
significant
utilize
deal.
the space station as a
And to improve the quality of those simulations, though, at this point, we have to have real-time data about that particle type and height.
Thank you.
Now, that's what the
we have
LiDAR can
members of
provide,
the news media as
in
well
particular
as
the
members of
vertical
social media who are
information.
attending the NASA
And
social
we have an
for the
animation, a third
SpaceX
animation to
CRS-5
show
launch.
that as we
And we
orbit
also
along,
have Jason
we build
Townsend
up this
from
profile
NASA Social,
information showing the height
NASA
and
headquarters, who is
location of the
taking
different
questions using,
features in the atmosphere.
hashtag Ask NASA. So
What's
feel free
important
to
here
ask
is
your
this data is
questions
going to
that
be
way if you're
coming to the
online.
ground in
And here in the room, please
continuous
wait for
near
the
real-time
microphone,
fashion. That's
state
a
your name and
capability that's made
affiliation, and
possible
to whom
by
you're
the space
addressing your
station,
question.
the space station communication
and we'll
infrastructure.
begin
We should be able to
here,
collect the
Alan, do you
data,
have any
transmit it
questions?
to ground, and have it into the models within about a 2-hour time
With
frame.
NBC News.
That's something we haven't
could you
been
talk
doing
about,
before.
what the
And it's
schedule
something
would be
that's
for
at this
deploying
point
CATs
uniquely enabled
and
by the space
also,
station's communication infrastructure.
when you expect the first light and the first results to come
In
about?
summary, then,
you.
CATS was a low-cost, cost-effective way
Sure.
to
But right
utilize
now, the launch
space
schedule
station to
for tomorrow
demonstrate new
morning,
technologies.
it docks
As
about
Julie
2
said, the
days
station's
later.
built. It's there. We can
Now,
use the
after that, something
infrastructure.
interesting
The
has to
cargo
happen.
rockets
I
are
didn't
going there. We
talk about
launch
it
as
before,
cargo,
but it is another
essentially.
first that
That
CATS
keeps
is
the
blazing
cost
away
very,
at.
very low.
They have to pull us out
Lets
of the
us
Dragon trunk
turn
with
things
one
around very
robotic arm and
quickly.
hand us over
We
to
can
another
take more
robotic
risk
arm
because it's a
to install us
demonstration
onto the
measurement,
station.
and it's a demonstration of
CATS is
technologies.
going on to the Japanese experiment
But these
module exposed
demonstrations and these new
facility,
measurements
GMEF,
will
as
find
it's
their way
called.
into future satellite missions, as
And,
Bob alluded.
This robotic transfer has to
CATS
be
will
carefully
obtain
coordinated
important new
between
Earth science
the US side
measurements, and
the
being able to
Japanese side.
utilize the space
It's the first time
station as a
they'll try one of these
platform
robotic
does indeed
animals.
begin a new and exciting era for
right
Earth
now,
science.
I'm waiting on what date that's going to happen. We think it's going
Thank
to
you.
be the 15th
We
of January.
have
roughly.
members of the news media as well as members
they
of
get us
social
over and
media
get
who
us
are attending the
installed into
NASA
the gym,
social for the
then we can
SpaceX
start through
CRS-5
the
launch.
turn on and
And we
check
also
out.
have Jason Townsend
It'll
from
take us a few
NASA
days.
social
We should be
at
operating
NASA
at this
headquarters
point
who
by
is
the
taking
end of January.
questions
Should be a
using
safe bet.
hashtag Ask NASA. So feel free to ask your questions that way if you're
Jason Ryan from
online.
SpaceFlight
And here in the
Insider.com.
room,
Some
please
notes
wait
to
for the
Julie. Julie, real
microphone,
quick, you
state
talked
your
a little
name
bit
and
about the,
affiliation,
experiments
and to
being
whom
done
you're
on
addressing
station.
your question.
And with extensions of the station
and we'll begin
proposed to 2024,
Here,
2028.
Alan, do you
Talk
have
a
any
little about the
questions?
Modular nature of the experiments on the
Alan
station. as
Boyle
well as
with
what we
NBC
expect to see
News.
in the future.
Could you talk about
Yeah, that's a great question.
what the
because
schedule
one
would
of the
be
things
for
that the
deploying
extension to
CATS
2024
and
would make
also
possible is almost a
when you
complete
expect
new
the first
suite of
light and the
instruments.
first
There are some
results to
instruments
come
that would
about?
continue
you.
operating and actually have a lifespan that could go as far as 2028
Well,
and are
right
getting
now, the
enough
launch schedule
operational
for
data
tomorrow
that if they're
morning,
running,
it docks
scientists would
about
want that
2 days
data.
later.
Then there's another
Now,
set of
after that,
instruments
something
that have
interesting
been
has to
built
happen. I didn't
to be
talk
tests
about it
that
before,
would
but
be
it is another
complete
first
with
that
their
CATS is
operations, or
blazing
maybe
the way
even
here.
be
They have
expected
to
to fail
pull
by
us out
then.
of the Dragon
And we can
trunk with
replace
one
all of
robotic
those
arm
and
and
have
hand us
another
over
suite
to
of
another
instruments up
robotic
through
arm
2028.
to install us
So
onto the station.
essentially what you're
So
doing by
CATS is
extending
going
to
on to the
2024,
Japanese experiment
you
module
almost
exposed
double
facility, or
the amount of
GMEF,
our
as it's
science and
called.
other external
And
payload data you can
this
collect
robotic transfer has
just
to
from
be carefully
2020 to
coordinated
2024
between the U.S.
by
side
having all of
and
those
the
sites
Japanese
full and
side.
used.
It's the
And of
first
course,
time
if
they'll
you go
try
to
one of these
2028,
robotic
you would get
handoffs.
a similar
So
kind of extension.
right now, I'm waiting on
So sort
what
of if you
date
look
that's
at
going
it
to
per
happen.
site year,
We
there's
think it's
enormous
going to be the
value
15th
to
of
having the
January,
platform
roughly.
available to get data like this.
Once they get us over and get us installed into
Jason
the
is
gym,
monitoring questions
then we
coming
can
in
start
on,
through the
hashtag Ask
turn on
NASA.
and check
Jason, do
out.
we have any questions?
It'll
Indeed,
take
we do
us
have
a few days.
here.
We
This
should
one
be
coming from
operating
Twitter
at
user
this point
Antoine,
by
who
the end of
asks,
January.
why is
Should be a
CATS
safe bet.
on the ISS and not a standalone satellite?
Jason?
Jason Ryan from SpaceFlightInsider.com.
Well,
This one goes to
because,
Julie. Julie, real quick, you talked
back
a little
in
bit about the
2011,
experiments that are being done on station.
the space
And
station
with
was
extensions
built,
of the station
Julie said,
being proposed to 2024,
and we had to start
2028, can you talk a
utilizing
little bit about the
So
modular
the
nature
ISS
of the
program
experiments on the station, as
proper
well as what we can expect to
wanted
see in the
to
future?
jumpstart
Thank you.
science utilization.
Yeah, that's a
and
great
specific
question
Earth
because
science
one of the things
utilization
that
of
the extension to
So
2024
they,
would make
approached
possible
us
is
directly
almost a
based on our
complete new
heritage of
suite of
building
instruments.
high-altitude
There are some
aircraft
instruments that would
instruments.
continue operating and
they
actually
also
have a
approached
lifespan
the-
that could
the
go
JPL
as far as
rapid
2028
factory
and are
launch,
getting enough
which Julie
operational
said
data
once
that
on
if
the
they're
last
running,
launch.
scientists would
And,
want
they
that
said,
data.
"Can you
Then
do
there's
something
another
quick
set
and
of
cheap?
instruments
You build
that have
these
been
aircraft
built built
instruments, they're high
to be
fidelity,
tests
they're
that would
autonomous.
be
It sounds a
complete
lot
with
like
their
our ISS
operations, or
platform.
maybe even be
We thought
expected to
about
fail
it
by then.
for a very
And we
short
can
time,
replace all of those
and,
and have another suite
we
of
agreed
instruments up through
collectively, yes, we could
2028.
build something like
So
that.
essentially what
And
you're
so they
doing by
chartered us to
extending to
go off and do this.
2024,
Now,
you
it's
almost
a-
double the
it's a
amount of Earth
stepping stone to
science
a
and
future free
other
flyer.
external
NASA has
payload
a-
data you
a
can
mission out in the
collect
future
just
called
from
haze, or
2020 to
the aerosol cloud
2024
ecosystem
by
mission.
having all of those
And a
sites
lot of the
full and
technology
used.
in the
And of
CATS
course, if you go to
payload is
2028, you would
testing
get
technologies
a
that we
similar
find
kind of
home on
extension
haze.
again.
So
So
we're-
sort of
we're
if you
a
look at
stepping
it per
stone, a
site year, there's
pathfinder,
enormous
but
value
we were
to having the
also
platform
a,
available to
an
get
important
data like this.
jumpstart to doing Earth science on station.
Jason is monitoring
add a
questions
couple
coming in
things.
on hashtag
So
Ask
the
NASA. Jason, do we have any questions?
administrators of
Indeed,
the
we do have a
Science
few
Mission
here.
Directorate
This
and
one
the
coming
Human
from Twitter user
Exploration
Antoine, who
Operations
asks,
Directorate
why is
had done
CATS
a call
on the
for
ISS
different
and not a
technology
standalone
demonstration
satellite?
ideas for ISS. Both CATS and RapidScat were
Well,
ideas that bubbled up through
because,
that call
back
as
in
early adopters,
2011,
basically, for the ISS slots.
the space
And,
station was built,
Since that
as
time,
Julie
there have been
said,
a number of
and
years of
we
competition.
had to start
and the
utilizing
Science Mission
it.
Directorate has
So
selected,
the ISS
multiple
program
different
proper
instruments to fly at different
wanted
times
to
all the way through
jumpstart science
2018
utilization
under the
and specific
regular,
Earth science
the regular
utilization of the
announcements of
station.
opportunity.
So they approached us directly based on our heritage
Brazil
at building
asks a couple of
high-altitude
things, looking for
aircraft
some numbers
instruments.
here. So what is the volume of
And
data
they also
per hour
approached
generated by
the
CATS?
JPL
And what is the
RapidScat
vertical
group that
resolution of
launched,
CATS in
as
meters?
Julie said, launched on the last launch. And they said,
Well, we can
can you do
adjust it
something
if we
quick and
wish once
cheap?
we're
You
on
build
orbit,
these
but,
aircraft
30
instruments, they're
meters
high
and 60
fidelity, they're
meters are our
autonomous,
standard
that
data
sounds a lot
products
like
in the
our
vertical.
ISS platform.
As far
We
as the
thought
data
about it
rate,
for a very
it's
short
about
time,
2
and
megabits per
we
second
agreed
continuous
collectively,
data
yes,
flow.
we could build something like that. And so they chartered us to go
Wonderful.
off
Another
and do
question
this.
here coming
Now,
from a Twitter user named
it's
Jeff.
a
How
it's
long
a
will the
stepping
mission
stone to a
last?
future free flyer. NASA has a
we're
mission out in the
approved to
future
be,
called ACE, or the
on the
Aerosol
JMEF
Cloud
for up to
Ecosystem
3
mission.
years.
And a lot of the
If we're still
technology
operating
in the
at the end of
CATS
3 years,
payload
we're
is
allowed to ask
testing
for extension
technologies that
beyond
would
that.
find a home on ACE. So we're a stepping stone, a pathfinder,
there's a
but
question
we
in the
were
back.
also an important jumpstart to doing
And
our
if you're in
science
the room
on
and you have
station.
a question, please raise your hand.
Just to
let
add
me
a
know.
couple things.
Stuart Muddy,
So
interspace.net.
the
And my
Associate
question, I guess,
Administrators
is
of the
maybe
Science
to
Mission
Robert or
Directorate and the
Julie.
Human
Has the
Exploration and
handoff been
Operations Directorate
practiced
had done a
before
call
with
for different technology
anything
demonstration
other- or
ideas
is this
for
the
ISS.
first
Both CATS
actual
and
handoff
RapidScat
from one
were
arm to
ideas
another?
that bubbled up through that call as
so we
early
have done some
adopters,
other
basically, for the
handoffs, not of
ISS
instruments.
slots. And
But-
since that
but,
time, there have been a
in
number
the
of
way
years
that
of
these are
competition, and the
practiced is
Science
really in a
Mission Directorate has
simulation environment.
selected
We have these very high-fidelity
multiple
robotic
different
simulation
instruments to
environments.
fly at
So
different
we don't
times
have
all the
any
way through
concerns that this is a
2018 under
high-risk
the
kind of mission
regular
operation.
announcements of
This is pretty
opportunity.
standard business for the robotics teams.
Twitter user Frazil asks
Daryl
a
Nail
couple
Fox
of things looking
35.
for some numbers here.
Can you
So
tell
what
me
is the volume
why,
of data per hour generated by
three-dimensional,
CATS?
cloud
And what is the
data
vertical
helpful
resolution of CATS in meters?
assessing, what kind of
Vertical
changes are going on in
resolution,
the climate?
well, we can adjust it if we wish once we're on orbit,
that's a
but
great
30
question,
meters and
Daryl.
60 meters are our standard data products in the vertical.
Radiation transfer
as far
is
as the
a
data
complex
rate,
thing.
it's
And
about 2
you
megabits
can
per
train it pretty
second
well in two
continuous data
dimensions,
flow.
But as we know, we live on a multi-dimensional planet here. So when you
Wonderful.
add a
Another
third
question here
dimension
coming
to
from
it, and
Twitter
you add
user
the
named
fourth dimension
Jeff.
of how it changes
How long
over
will the
time,
mission last?
You get a better handle on how the sun's
We're
incoming
approved to
radiation is
be
being bounced
on
around
the JMEF
inside
for
a
up to
cloud.
3
What I
years.
neglected to say,
If we're
we are
still
interested in
operating at the end of
aerosols
3
because
years, we're
aerosols
allowed to ask
provide
for extension
seed
beyond that.
particles for cloud droplet formation.
Okay.
You change the nature
Do we,
of the aerosol in there. You
there's a
change
question
the
in the
nature
back.
of the clouds. You change the nature of particle.
And
cloud
if you're in the room and you
condensation
have a
nuclei,
question, please
how
raise your
many
hand,
there
let me
are,
know.
And you can change
Stuart
the
Muddy,
nature of the cloud to go from
interspace.net. And my
precipitating
question,
to
I
a
guess, is
non-precipitating
to maybe
cloud,
to
from a
Robert or
cloud
Julie.
that absorbs
Has the
radiation to a
handoff
cloud
been
that scatters
practiced
radiation.
before
Now, by
with
having three-dimensional
anything,
information, we
other,
can
or is
see
this the first
in the
actual
atmosphere
handoff from
where it
one arm
is
to another?
that the cloud is being
So we have done some
intersecting
other
with the
handoffs, not of
incoming solar
instruments,
radiation.
but
can then model what the
in
impact is in terms
the
of
way
how
that
much
these are
radiation makes
practiced
its
is
way
really
down
in a
to the Earth's
simulation
surface,
environment.
and
We
how
have
much
these very
radiation
high
is
fidelity
scattered
robotic simulation
back into the
environments.
atmosphere and how
So we
much
don't
back
have any
into
concerns
space.
that this is a
Without
high risk
that
kind of mission
good
operation.
vertical resolution,
This is-
we're a little
this
bit
is
lost.
pretty standard
30
business
meters
for the
may not
robotics
sound
teams.
great to a lot of people, but compared to what
Daryl?
we're working with now,
Daryl Nail
this
Fox,
is
35.
quantum leap
Can you
growth
tell me
to be
why
able to do that.
three-dimensional
The
cloud data
computing
is
power
helpful
catching
in,
up with the
in assessing
observations, and we're now able to ingest
what kind of
into
changes are
complex
going on with
models
the climate?
the kind of information
that's
that
a-
allows us
that's
to
a great
handle what
question,
three-dimensional
Daryl.
does. These big thunderstorms we had yesterday.
It's
They
radiation
interact
transfer is
with
a
the,
complex thing,
radiation, incoming
and
solar radiation differently than
you can
stratus
constrain it
clouds
pretty
we
well
had
in two
this morning.
dimensions. But as we know, we
Okay.
live on a
And
multi-dimensional
right now,
planet here.
being
So when
able
you
to
add a
look
third
at it in the
dimension to
vertical
it, and you
where
add the
these
fourth
things are,
dimension of
gives
how
us
it
a better
changes over
handle.
time,
I guess
you get a better
part of
handle on
answering
how
question
the sun's
is-
incoming radiation is being bounced around inside a cloud.
what I neglected to
example,
say,
which is
we are
you don't know
interested
how
in
thick the
aerosols
blanket
because
is, you don't know how
aerosols
much insulation
provide
it's gonna
the
do.
seed particles
just in a
for
very
cloud droplet
non-technical way, I think
formation.
everyone can
You change the
understand
nature
why
of the
knowing the
aerosol
cloud
in there, you
temperature
change the
matters.
nature of the clouds.
if you
You
change
change
the
the
material
nature
of
of
the blanket,
particle
it can either be
cloud
warmer or
condensation
colder.
nuclei, how many there are, and you can change the nature of the cloud to go from a
Jason Lyons,
precipitating
Spaceflight
to a
Insider.com.
non-precipitating
Julie, back to
cloud,
you.
from a
I'm
cloud that
getting word
absorbs
there's been a
radiation
little
to
bit
a
of
cloud
hiccup
that
with
scatters
Robonaut, and
radiation.
I'm
Now,
not
by
sure you
having
can talk a whole
three-dimensional
lot about
information,
that,
we can
but can you
see
tell us what's going on with
in the
this
atmosphere,
humanoid
where
robot
it
you guys
is
got on station?
that the
Well, you've got
cloud
your
is
computer
being
in front of you and I don't,
intersecting
so
with
I'll have
the
to find out what's
incoming
going on with
solar
Robonaut, maybe
radiation.
tell you the next
We
briefing.
can then model what the impact is in terms of how much radiation makes its way
seeing
down
no
to the
other
Earth's
questions,
surface and how much
Julie, do you
radiation
have
is
any closing
scattered
remarks for this briefing?
back into the atmosphere and how
yeah,
much
just to
back into
close out, I mean,
space.
it's been great to
Without
work
that
with Matt
good
in-
vertical
as he
resolution,
was,
we're a little bit
leading
lost.
Goddard in
30 meters
developing
may
the
not sound
capability to
great
build
to a
an
lot of
instrument
people,
for
but compared to
ISS.
what we're
We
working
now
with
have
now,
two
that
NASA
is,
centers
it's
with
almost
that
a quantum leap
experience,
for us
'cause JPL has
to
built
be able to
RapidScat.
do that.
There are other NASA centers
The
working to
computing
build
power is
payloads,
catching up
such
with
as
the
Cream,
observations, and
which
we're
will
now
go up
able
in
to
the coming
ingest
year.
into
It's
complex
really an exciting
models
time to work
the
with
kind of
our science fiction
information
directorate
that allows
colleagues
us to get a
and
handle
start
what a three-dimensional
testing
does. These
technologies,
big
trying new
thunderstorms we had
instruments, filling
yesterday,
gaps, and really making the
interact
ISS
with the
serve
radiation,
the
incoming
planet
solar
in every
radiation
different way
differently
it
than
can.
stratus
And
clouds
it's
that we had
exciting to
this
see that
morning.
capability maturing
Okay,
and growing in
and
ISS.
right
So
now,
we're excited, and
being
for the
able to
CATS
take a look
launch
at it
and
in the
looking
vertical
forward
where these
to
things
first
are
flight.
gives us a
First
better
is
handle.
The first images
I
from the
guess, I hope I answered that question the way.
And to find out more about
that you needed.
cats, you
And
can
I'll give
visit
you my
www.nasa.gov/cats.
example, which is if you don't know how thick the blanket is, you don't know how much
And to find out
insulating
more
it's
about how
gonna do.
NASA is using
And
the
so just in a
vantage
very
point of
non-technical
space
way,
to
I think
better
everyone can understand
understand
why
and
knowing the
protect
cloud thickness
our
really
home planet.
matters.
Visit
And if you change the material of the blanket, it can either be warmer or colder.
www.nasa.gov/earth right now. And as Julie mentioned, we have
Jason.
another briefing coming
Jason
up
Ryan,
on which she is going to
SpaceflightInsider.com.
be a
Julie,
panelist
back to
with
you.
some other folks.
I'm getting
That
word that
briefing
there's
begins
been a little
at
bit of a
1:30
hiccup with
p.m.
Robonaut,
here
and
on
I'm not sure you
NASA
can
television
talk a
and
whole
on
lot
the
about
NASA
that.
website.
But can you tell us what's going
It's
on
an
with
ISS
this
Research
humanoid
and
robot you guys got on
Technology panel,
station?
and we'll see you
Well,
then.
you've got your
Thanks for
computer in
coming.
front of you and I don't, so I'll have to find out what's going on with Robonaut, maybe tell you at the next briefing.